Hi everyone, this is Mrs. Kovacs. In this video, I'm going to show you how you can solve equations involving absolute value. To get us started, let's think about what absolute value even means. I'm thinking of a number whose absolute value is 3. What could my number be? Well, if we're going to answer this question, we need to know what absolute value is. So absolute value represents a number's distance from 0. So that's the definition of absolute value. We're trying to think of a number whose absolute value, or in other words, whose distance from 0 is 3. So if we're starting from 0, this is our starting point, we want to create a distance of 3. One way we could go is the negative direction. That'll have a distance of 3 when we land at -3. The thing about absolute value is there are two sides to 0, so there's usually two ways to get the absolute value of a certain number to be, in this example, 3. That means that our two solutions are going to be +3 and -3. The algebraic equation that we just solved was the absolute value of x equals 3. In order to solve it, we realized that there were two things that we could do, or two ways that we could have a distance of 3. We could say that the number was +3 or -3. And that's the kind of most basic kind of absolute value equation that you're going to solve. Let's go ahead and look at some more complicated examples. For our first example, we'll look at the absolute value of x minus 2 equals 5. What makes this problem different from the last problem is that there's an expression x minus 2 inside of our absolute value. I'm going to ask us to ignore that for a second and realize that the structure of this equation is exactly like the one that we just looked at. The absolute value of something equals 5. So when we're looking at a number line and we want to be 5 away from 0, we see that there's two options. We could be at -5, or we could be at +5. To represent those two solutions, we're going to set up two equations. And we're going to realize that whatever our question mark is, whatever it represents, the final value has to be equal to 5 or -5. Now let's remember what that little expression was. It wasn't a question mark, we're in algebra here. That was really x minus 2. Now we have two equations, x minus 2 equals 5 and x minus 2 equals -5. We'll solve them one by one. If you need a refresher on solving, I have a video on that. Go ahead and check it out on this YouTube playlist. Oops. The nice thing about solving an absolute value equation is that your solving steps are going to be identical in both cases. The only thing that's different is that whatever you're adding together is different. So like in this case, instead of getting 7, I'm going to get -3. Since this is an equation, you can check it, which is great news, just to make sure you didn't make any silly mistakes. As with any other equation, the way that you're going to check is by plugging it back into the original equation. Absolute value of x minus 2 equals 5. We're going to replace x with what we just found, which was 7. So absolute value of 7 minus 2 equals 5. Absolute value of 5 equals 5, which is a true statement. This right here, this 5, was what we were originally setting up as our question mark. We'll do it again for our second solution, -3 minus 2, absolute value of that equals 5. It is true that the absolute value of -5 equals 5, so that means that both of our solutions worked, we didn't make any mistakes, and we're good to go. Let's take a look at our second example. For our second example, we have a slightly more complicated expression inside of our absolute value, but that is totally okay. We're going to deal with it just the same. First, I ask you to recognize that this problem is exactly like the other ones we were looking at in its structure. The absolute value of something equals a number. For that reason, we're going to start it in the same way, recognizing that there are two numbers that have a distance of 15 from 0, positive 15 and negative 15. So that means that our question mark, the thing that's inside of our absolute value, could be positive or negative 15. Here's where the algebra part comes in and the solving. We didn't have a question mark there. That question mark really was 4x minus 1. So I replaced the question mark with 4x minus 1, and now I'm ready to solve each of my equations. Again, if you're confused about this solving process, please go ahead and take a look at my solving video, which hopefully will clear up any confusion you have about how to solve these two-step equations. If you're starting to panic that negative 14 isn't divisible by 4, please don't. At least for my class, I'm okay if you just leave your answer as is. A lot of people will ask you to simplify your answer into a simpler fraction, which we can do because both of these numbers are divisible by 2. So if you wanted to be really mathematical, you could write it in simplest form as negative 7 over 2. If you really wanted to, you could also write it as a decimal, negative 3.5, but personally, I'm not a big fan of decimals because unless they're like a terminating decimal like 0.5 or 0.08, sometimes that causes issues with your precision. All right. That was our second example. In the previous example, I showed you how you could check. Remember, you can plug both of those numbers into your original equation and make sure it works. I'm not going to show you how to check these because I feel like once you've seen one example, you kind of can do the rest. So let's move on to our third example. For our third example, we have the absolute value of x minus 2 equals negative 5. Once again, we have a basic setup of the absolute value of something equals a number. Unfortunately, there's a little problem. We're looking for a number who has a distance of negative 5 from 0. If I was going to move to the left, I wouldn't say that I was moving negative 5 feet, right? We don't usually measure distance in negative numbers, and that's true mathematically as well. So in this case, we'd actually say that there is no solution because distance can't be negative. So just keep in mind, you're allowed to have negative answers. Like for example, up here, we got x equals negative 3 as one of our potential solutions. That's something that we can plug into an absolute value equation. However, if our setup says that the absolute value of something equals negative 5 or equals a negative number, that's going to cause an issue because we can't say that the absolute value or a distance has a negative value. As our final example, we're going to step it up a little bit and look at something that's not in the correct form. Notice here how all of the other problems we were looking at said the absolute value of something equals a number. And before we can start thinking about our positive and negative solutions, we actually need it to be in that form. So let's get it there. To start things off, we'll add 13 on both sides so that the part with the absolute value is isolated. Second thing that's weird about this one is that we're equal to 0. A lot of people get really freaked out here. 0 is a number. Please do not be alarmed. 0 is a number just like any other number. The solution is going to be a little weird, but that's okay. 0 is still a number. We can still solve with it. So now we're at the point where we have the absolute value of something equals a number, and we're able to do our positive and negative solution. The interesting thing about this is that positive 0 is the same exact thing as negative 0. So this is the only case where you're going to have just one solution. You do not need to separate into positive 0 and negative 0. That would be a little bit redundant, not entirely wrong. You would still get the same answer, but that's the point, is you would get one answer, not two answers. So the way that we can solve this is by just saying that question mark equals 0. As we know, we were not dealing with a question mark. We were dealing with an expression. That expression was negative 2x plus 5. And we can go ahead and solve from here. Subtract 5 to get negative 2x by itself. Then divide by negative 2 to finish isolating x. And that is our singular answer for this absolute value equation. So those are the 4 examples that I have for you of solving absolute value equations. Let's go ahead and look at some things to remember. First up, when we were looking at the equation, the format was that we had the absolute value of something was equal to a positive number. In order to solve, we separated out our absolute value bars into a positive solution and a negative solution. There were 2 weird cases that we looked at. One of those cases was when the absolute value of something was equal to 0. In this case, since we don't really have positive or negative 0, we just had one solution. We just solved when the value was equal to 0. The second weird case that we came up against was when the absolute value of something was equal to a negative number. In that case, there was no solution because remember, absolute value represents a distance and distances can't be negative. I hope you learned something and have a great rest of your day.